Okay, here we go with exercise 10F, question 4, and it's 4C, which is causing the bit of confusion. So I'll go over part A and B first, just because it's good practice to see how we'd lay it out, and then I'll go into a bit more detail on part C. I'll probably do that as a different video. Okay, two particles, A and B, of masses 5 kilograms and 3 kilograms respectively, are connected by a light inextensible string. Particle A lies on a rough, that's weird that it's rough. The only reason they're going to tell me if something is rough is because there's going to be friction involved, yeah, which will oppose the motion. And the string passes over a small, smooth, no friction, pulley which is fixed at the edge of the table. Particle B hangs freely. The friction of A and the table is 24.5 newtons. The system is released from rest. Okay, no diagram this time, so I'm going to draw it here. This is a table. And then I'm just going to draw, let me draw that a bit more bigger actually so I can see a bit more clearly. So this is going to be my pulley. Then my particle comes along here, particle A. Is particle A? Yeah, particle A is the one that's on the table. So that's A. And what did it tell us? It told us that it had a mass of 5 kilograms. Done this bit small, just fit it in. Okay, then this is my pulley. And particle B is going to come over this pulley. It's hanging freely. Particle B hangs freely. And that had a mass of 3 kilograms. Now, the bit of additional information that they hadn't told us before is that particle A lies on a rough horizontal table. The friction between A and the table is 24.5. When this system is released from rest, it doesn't matter really that this particle is heavier than this particle because this is being pulled down by gravity. It means that the system is going to move along this way and move down this way. Okay, right. So let's have a think about what's going on. I'm always going to label my tensions first. So my tension is going to act against this because that's the thing that's going to be slowing it down. Then this tension is going to be acting on the pulley. This tension is also acting on the pulley. And this tension is the one that's going to be pulling this particle along. Then we've got one more thing as well. We've got this friction acting between the table, which is 24.5. So that's another force. You know it's a force because it's in newtons, which is 24.5 here. Okay, any other information I need to worry about? No, I don't think so. Okay, right, the acceleration of the system. Now, I'm going to sound like a stuck record, but I always want you to do this. I'm going to look at the forces. Whoa, I've forgotten something. Okay, so the thing hopefully that you've realised I've forgotten is the weight of this is obviously the force which is going to be acting down. So if that's got a mass of 3, the weight acting down will be 3g. I could have, if I wanted to, I could be putting on here the weight acting down because there is the weight of this particle acting up here. And there will be a normal reaction coming from the table as well. But I don't need to consider this for the movement of this here. And I will do probably next year, I think. We'll probably see problems where we do need to be considering those things where the friction is dictated by what the reaction is. But for now, let's not worry about those things. Okay, so got everything I need on here? Yes. Find the acceleration of the system. Right, I'm just going to look at A first. So for particle A. I'm going to construct an equation. Look at all of the forces just acting on A. These are all my forces acting on A. I'm going to say to the right is positive, so I'm going to resolve. I've got T minus 24.5. So that's me working out the forces. So T, that's the positive direction, minus 24.5. Any others? No, equals the mass, which for this particle was 5, times the acceleration. Two unknowns, I can't work out anything yet. Right, now I'm going to look for B. And let me look at the forces acting on B. So for B, we've got, I'm going to call down positive, because that's the way that it's accelerating. Down is positive, therefore I've got 3G minus T equals 3G minus T. Any other forces? No, these are the tensions just acting on the pulley, equals the mass, which is 3 times acceleration. Okay, here I've got two unknowns, A and T. Here I've got two unknowns, A and T. Hopefully we can realise now, two equations, two unknowns, we should be thinking simultaneous equations. So I could do whatever I wanted to here. I might rearrange to make T the subject of this. What instead I'm maybe going to do is just rearrange this to make this minus T, add 3G equals 3A. Because if I do that, then I'll just plonk this over here. So I've got minus T, add 3G equals 3A. Because then when I add those two things together, it's going to give me that, those cancel. Then I've got essentially, hold on 2 seconds, let me work this out. Minus 24.5. Managed to source a calculator, by the way, guys. 4.9 equals 8A. If you're confused what I've done there, I've just done 3 times 9.8 and then minus 24.5, add 3 times 9.8 will give me 4.9. Therefore, A equals 4.9 divided by 8, which equals 0.6125. Now, this is a weird quirk of the mechanics stuff. It wants you typically to round these things to 3 significant figures. If in doubt, round it to 3 significant figures. I find that a little bit weird because G is detailed to 2 significant figures, but if in doubt, round to 3 significant figures. So that's why the answer on the mark scheme is 0.613. When I start giving you exam questions, you'll see that they often round the answers to 3 or 2 significant figures. I think if in doubt, round it to 3 significant figures. Okay, right. So that's part A. Part A. Part B is pretty much done for us anyway. Part B, the tension in the string. I just take either of my equations. Let's just take this equation. I've got T minus 24.5. What? Particularly bad handwriting there. Equals 5A. But this time I've worked out the value of A. If I then substitute that in, you should have got T equals whatever. Sorry, let me just write that out so you can see it more clearly. Equals 5 lots. I'll probably use the original value here, 6125. And then you work out that T is... Okay, right, I'll show a separate video on how to work out the magnitude of the force exerted on the pulley, because it's a bit of a weird one. I'll try and do it. It's a bit too small the way I've done it here, so I'll do it on a separate diagram. Keep up the hard work. Bye.